Today we'll look at an alternative method to Gauss's law to determine the electric field for a continuous charge distribution. And for a single charge, we had the electric field was equal to the charge over 4 pi by the permittivity of free space, and that's multiplied by the radial distance from the center of the charge squared. And we multiply by the direction vector. Now if we have a distribution of charges, so for example along a wire, and I suppose we look at two finite points and we want the change in electric field between those points. Well, the change in electric field is proportional to the change in charge between those 2 points. And now using the superposition principle, we can sum up all these changes over the number of charges that we have. So from I equals 1 to the number of charges, and we assign the index I to the change in electric field and the change in charge. And now taking the limit on both sides, as the number of charges goes to infinity, we get a continuous charge distribution. And we turn this sum into an integral. So on the left hand side, we obtain the total electric field due to the continuous charge distribution, and then take the constants outside the integral, so 1 over 4 pi by the permittivity of free space, and we integrate over the charge on r squared in the direction r. And now we can determine a few expressions for dq based on a charge density. So if we have a one-dimensional charge distribution, such as along a wire, we have a charge density lambda, and we can write dq is equal to lambda by the change in length. So this charge density is in coulombs per unit length, and we multiply by the differential change in length, and then perform the integration to get the net electric field. Now similarly, for an areal charge distribution, well, if we have an area such as a plate, so the differential element is going to be dA, and we multiply this by the areal charge distribution. So that will be in coulombs per unit length squared, multiplied by an area. And similarly, if we have a volumetric charge distribution, that's rho, and we multiply that by the differential volume element. And what we'll do is use this integration method to determine the electric field for several cases with a continuous charge distribution, and compare the result to Gauss's law. And I'll see you in the next video.